Bismillahirrahmanirrahim. Dear students, welcome back. Today is our second lecture, which is on the graphical representation of friction. Graphically, we have to represent that how friction changes by applying some force, and which kind of friction is that, either static or kinetic. You already know that whenever an object is slide against the other object, then there is opposition created which oppose the motion of object. That opposition is actually a force, which is frictional force. So let us start that how graphically we can represent these frictions, and how kinetic friction and static friction are correlated with each other. From the diagram you can see that along x-axis it's applied force, and along y-axis it's frictional force. So let us start from a simple description, and then we will draw the graph. Here let us consider that that we have a tabletop, and at that tabletop we have a box like this. So simple. If you are going to apply some force here, this is applied force, then the frictional force will be in opposite direction, and this frictional force will opposes the motion of this block against the tabletop. So graphically, if we draw these things like this, along x-axis this is origin, along x-axis we will just show F, that is applied force, and along y-axis we will represent friction, and we will here draw kinetic and static both frictions. So here we can say that this is frictional force. So let us start drawing the graph. For example, if you are applying this force in this direction, and friction force will appear in this direction, and block is not moving, what kind of friction is that? Static friction. And if you increase this applied force, then value of static friction will increase. As for example, if 10 Newton of applied force is applied, then 10 Newton of frictional force will be created. Then if applied force is 20 Newton, you increase the value of this, then the friction will be also of 20 Newton. So these things are directly proportional to each other. As in graph, if we will show this relationship is just a straight line like this, right? Because these two things are directly related with each other, and this region like this, see here in graph, this is straight line, and straight line will show that as you are increasing the applied force, the frictional force will also increase, and this frictional force is actually static friction. So that's why we can write here that static friction is almost equals to that applied force. I already gave you this example by giving some magnitude of forces also. So what happens next? At a peak point, there is a certain limit. Then the block will start moving in the direction of applied force. So for example, block will slide little bit here. If block will slide little bit here, it means that the block is moving in forward direction, and now friction is present there, but the friction is not static friction. Friction is now kinetic friction. So this region from 0 to this peak point is actually the value of static friction at its maximum point. When it will reach at its maximum point, after that static friction will be finished, and the kinetic friction will start, because the body is moving. So this region is called static region, right? Now what happens when this box will slide little bit in this direction, then it will slide more, then it will slide more, and it will move in this direction, because you are increasing the value of applied force, and the peak value of static friction also appears here. After that there is no static friction, the friction is kinetic friction. So what is going to be happen now?